All right, today the topic is point-slope form. So we talked about slope-intercept form, and you hear about that one the most in earlier math classes like algebra. But I know that once you get into higher math classes like calculus or pre-calc, point-slope is used the most only because they're the least number of mistakes made depending on what you are given. So the point-slope form is just as important and very easy as is slope-intercept, depending on what you're given, what information is provided to you. So the learning target today is I can write an equation in point-slope and slope-intercept form, because for the assessment you're going to have to go through 3 different forms of a linear equation. So here are the different ways that you can write a linear equation in 2 variables or 1 variable. The slope-intercept form of a line, you know, is y equals mx plus b. We have talked about vertical lines and horizontal lines to some extent. We'll get into that more. And then the standard form. The standard form is ax plus by equals c. It is the point-slope form that we're going to be talking about today. So point-slope form is y minus y sub 1, where this is the y-coordinate of a given point, equals m, which is still our slope, times x minus x sub 1, where this is the x-coordinate. So this y and this x is the same as this x and this y. So it's the variables in the linear equation, where this is going to be a number, this is going to be a number, and this is going to be a number. It is really, really easy if you're given the slope and a point to just slam it in there and not have to worry about going any further. So here's an example. So here's that form, like y equals mx plus b, without any numbers in it. But once we put numbers in, we can see that our slope is 4, and our point, now this is where you have to really pay attention to the signs, it's minus y sub 1 and minus y sub 2. So even though this says minus 2, sorry, I think I said it's x sub 1. I don't know what I just said. X sub 1. So it's because this is subtraction, we know that this is going to be a positive 2. This is subtraction, so this is going to be a positive 3. If it had been plus, then it would have been like minus a negative. And so x sub 1 would have been negative 2. But it is not. It is minus. So it tells us that one of the points on that line, and remember this is all about a graphed line, so the slope is 4, and one of the points is 2, 3. So remember, the x is over here, the y is over here. So we could graph the point by locating 2, 3 on a coordinate plane. Let's say it's about right there, and then going up 4 over 1, up 4 over 1. To get that graph line. So for this slide, we have 2 different things that we need to do. First, we need to write it in point-slope form, and then we need to go back and write it in slope-intercept form, and it really is easy to do. So I'm going to do the first one with you, and then pause so you can try these 2 on your own. So here, I know that this is my overall, so I'm going to start with y minus, and I'm going to look to see, here's my x, here's my y. So sometimes the biggest mistake is the mind plays tricks on you and you want to grab that first number, but really it is the second, so be careful with that. Don't let your mind play a trick on you. It says minus and then a negative 8. So I'm going to right away, so I don't forget, change it to keep, change, change. So really it is y plus 8. And then m, my m right here is 4/5. And then it is x, and then I'm going to go back and get my x, minus a negative 14, keep change. So now I have y plus 8 equals 4/5 times x plus 14. Ooh, I chose the worst one to go through. So now it says to go back and write it in slope-intercept form. So generally this is very easy, but because I have fractions, it's a little icky. So I'm going to go like this. So here we have y plus 8 equals, so just distribute that out. 4/5 x plus, and now here this is the icky part, 4 times 14 and then over 5. So 54? 54/5. And now I have to add this 8. So I'm going to change this 8 into something that's fifths. 8 is 40/5. So I am going to, I said add, subtract 40/5. So now I have y equals 4/5 x. 54 minus 40 is 14. So I have 14/5. And now it is in slope-intercept form. So my slope would be 4/5, and my y-intercept would be 14/5, which is almost 3. But you could stop right here. All right, so I just cleaned the paper off so you would have room to write. What I would like you to do is do B and C. First put it into point-slope form, and then see if you could use your distributive property inverse operations to get it into slope-intercept form like you did on the last lesson. So solving for y, and then come back and see how you did. All right, so let's see how you did. Hopefully you're actually doing this instead of just skipping forward. You don't know if you can do it unless you try. Okay, so first I put it in point-slope form. So here's my slope, and here's my point. So y was 3, and x, since it was a -1, minus a -1 is +1. And then after that, I just use the distributive property. Don't forget to change the signs. Some of you are still dropping negatives, and then it was -3, so I added 3, so that would be like a -2 plus 3. -2 plus 3 is 1. So here is my equation in slope-intercept form. Now I like to, because I make math errors all the time, I like to double check. So what I did was I took my x of -1 and I plugged it in. So -2 times -1 is 2. 2 plus 1 is 3. So I know that that works. For the second one, I started with my point-slope form. So y minus my y here, so y minus 7 equals 12, which is my slope, times x minus 0, which is my x. So some people right here, they don't even put in the 0, and that's okay. So if you had just had 12x, that would have been fine. But generally, because we want to see that point, I suggest you just leaving it minus 0. So now we can see that point. Now, I don't have any work shown here because I know that I need to get it into slope-intercept form. I need my slope and I need my y-intercept. The y-intercept is the value of y when x is 0. So I could go straight from this and put it into here. So I didn't have to distribute it out or anything, but if I did, this would have been 12x plus 0, or just 12x, and then I would have added 7 to both sides to get this. So it is so easy to go from point slope to slope intercept. All right, how do we get it in point slope form if we're not given the slope? Is it even possible? Can we do it? Of course we can, because we know how to find our slope. Remember, that's the y over the x. So the y change over the x change. So my y change, and I don't care which direction, matter of fact, I think I'm going to go the other way. I think I'm going to go this way. 7 minus 4 over, I got to start here and go to the right because I did the first time, 5 minus a negative, 5 minus a negative 4. So now I have 3 over, sorry about the barking. Sorry, they really were sleeping when I started this. So now I have 3 over 9, which is 1/3. So now I know my slope. And I can go from there. When you're writing something in point slope form, it does not matter which one you choose. You could choose to use this one, you could choose to use this one. It really does not matter. Both would be correct. So I'll just do the first one. So y minus, I'm going to go over here and write x and y to make sure I grab the right number, equals 1/3 times x minus, I'm going to come over here and grab that 5. Oh, another fraction one. What am I doing to myself? So that is in point slope form. To get it into slope intercept, you do that distributive property. So I have y minus 7 equals 1/3 x minus 5/3. And then I'm going to add 7. But if I need it over here into thirds, I'm going to make it. 7 is the same thing as 21/3. So I'm going to add 21/3. So now I have y equals 1/3 x. Now remember, this right here is minus 5/3, so I'm going to change it to adding the opposite so I don't forget. So 21 plus a negative 5, or 21 minus 5, is 16/3. A positive 16/3. So I hope I did that math right. For the sake of time, I would like you to try one on your own. So please find the slope and then put it in point slope form and slope intercept form, and then come back to see how you did. All right, let's see how you did, or how I did. Maybe I did something wrong. So make sure if you don't match an answer of mine, did you make an arithmetic error, or because I'm distracted by the dogs, did I make an arithmetic error? So the first thing I did was y minus 2, because I went over and I got my 2 from over here, so I subtracted the y, equals, oh wait, back up. So the first thing I did was the slope. 4 minus 2 is 2, negative 4 minus a negative 3 is negative 4 plus 3, which is negative 1. So my slope is negative 2. So I got the y, I put the slope in, and then I got the x. So it was x minus a negative 3, so I made it plus 3. So this is point slope form. And then to get it into slope intercept form, I just needed to use the distributive property and then bring that other number over so y is on a side by itself. So my slope is still negative 2, and then it passes through the y-axis at 4. All right, 2 more problems. With word problems, I always look to see what is given to me. So here, it was 20 inches tall after 3 weeks and was growing at a rate of 2 inches per week. So it doesn't give me the beginning. It doesn't say at the beginning it was 20 inches. It says that after 3 weeks it was 20 inches. So remember, your time is going to be your independent variable, and the height is going to be your dependent variable. So here, my point, it gives me a data point. After 3 weeks, it was 20 inches. And it's growing at a rate of 2 inches per week. So I'm given the 2. So it says write an equation. It does not say, I did not put in here specifically write a type of equation. I didn't say you had to write it in both ways. I just said write an equation. So which form would be the easiest to use? Well, if I'm given a point and I'm given the slope, point slope would be the easiest. So y minus 20 equals 2 times x minus 3. So here's my slope. Here's my slope, here's my x, and here's my y. If you wanted to put it in slope-intercept form, you could, but again, the more calculations you do, the more chance there is of error. So I would stop right there. That's the most efficient way. All right, a student was sequestered for work completion. He had 10 assignments done after 1 hour and 16 assignments completed after 3 hours. So what are we given? We're not given the rate, and we are not given a beginning point, so we just know a data point. So again, you have to think about what is your x and your y going to be? Well, what is changing? The hours, like the hours going on, and what's dependent on that is the number of assignments. So the hours are going to be your x, and your assignment is going to be your y. So this one, these are your independent variables, and the assignments are your dependent variables. So we have our 2 points. After 1 hour, he completed 16 assignments. Oops, sorry, he had 10 assignments after 1 hour. And after 3 hours, he had 16 assignments completed. So now we need to find the slope. You can't write the formula, you can't write it in any form without the slope. So I'm going to find my slope. 16 minus 10 is 6. 3 minus 1 is 2. So now I have 3. So I know he's doing his work, or he is doing his work at about 3 assignments per hour. So now I can write my equation. Y equals, I said that wrong, y minus 10 equals 3 times x minus 1. And I could stop there because all I asked for was an equation. If, however, I asked how many assignments did he start with before he got sequestered, you could find that beginning point. And remember, the beginning point is B, your y-intercept. So you could stop right here. That would be sufficient. But if I asked a question, you might need to take it one step further. Y minus 10 equals, so I'm just distributing out and putting it in slope-intercept form to find my beginning point. So this is telling me that he started with 7 assignments, and he was doing the assignments at a rate of 3 assignments per hour. So you could have stopped here if there was not a question to be answered, or you could have taken it further if there was a question to be answered. All right, hopefully that helps you with this assignment. Please, if you get stuck, ask, ask, ask. All right, we out.